one butane to the one bromine butane. So one butane is a double bond in that way, the one positions. So you get the more substituted side, less substituted side. The product, you add a bromine, goes to the less substituted side, right? Bromine goes to the less substituted side. Well, one of the way you can easily figure out what's the Markov nickel. I mean, the question is, I put you already here. When you see a product, you need to figure out, is this the Markov nickel product or the anti-Markov nickel? I mean, of course, I mentioned there, but I think just ignore that one. Just forget about you seeing that one. What is the way to figure out the product that you see is a product of the Markov nickel or products of the anti-Markov nickel? Is you need to look at where the nucleophiles goes. Right? If you remember that, electrophiles are talking about regular Markov nickel addition. Electrophile typically goes to the less substituted side. So that you can make a more substituted carbon, becomes a more stable carbocation. The nucleophile goes to the more substituted side. That's the feature of the products made by the Markov nickel addition. Is this the Markov nickel products? You need to look at the word nucleophile bank. The bromine is on the one position. We talked about between 1 and 2 carbon. This is the 1, that's a 2 carbon. Bromine can be added to this position or that position. Which position is a more substituted? 2 position, not the 1 positions. Bromine going to the 2 position is the product made by the Markov nickel addition. This one, bromine is on the 1 position, which means the bromine is on the less substituted side. To make this way, to make the bromine edit this way, you cannot do it the regular way. Because if you do it the regular way, the bromine will go the other position. So this one is called anti-Markov nickel products, which means that you have to change the order of the addition by going into radical pathways. So this is something we learned. That you add a peroxide, that could be hydrogen peroxide, or there will be alkyl peroxide. If you heat it up, it breaks it up, it makes a radical forms. This oxygen radical is going to abstract the hydrogen. That makes a bromine radical. So basically, that's the initial steps. That's going to be added first, but that additions go to the less substituted side, right? So that more substituted side becomes a radical, more stable radical. And that's going to get the hydrogen from HBr. So you get these anti-Markov nickel addition products made. If you want to make a 2-bromobutane, now the bromine is on the more substituted side, hydrogen goes to less substituted side. This is the product of the Markov nickel addition. So for this one to be made, you only need to add HBr. That's it. You need to figure out which reagent you're going to use for the what circumstances, right? That is something you also need to figure out for the question in the next test. HBr addition, hydrogen, the bromine, the proton is going to be added first. Proton goes to the less substituted side, so that the more substituted carbon becomes a carbocation, and then that captures the nucleophile, and you're going to make this. So not only you understand what reagent does what, there is probably going to be paired up to make the reaction go the other way. Not only that, you need to look at which side is going to be having what, so regiochemistry. And what makes it more complicated in the end is a stereochemistry. This one, thankfully, we don't have to talk about stereochemistry because it's going through the carbocation intermediates. Carbocation intermediates is a flat structures. So reaction can happen from the top 50%, bottom 50%. So we don't expect any stereochemistry. But other reactions that you need to think about. Every single reaction you need to think about one that goes in the Markov nickel way, another reaction goes the anti-Markov nickel way, what are the changes to make that happen, regiochemistry and stereochemistry. Every single reaction we're going to talk about in the table in this section.